Yet another way to graphically describe what's going on is what's called a streak line. Experimentally, or like you can think about what a streamline, a streak line is by thinking about like having a continuously released fluid that is released from some point, and then following that over, following how that line remains together over time. So basically, a sprinkler is a really good example of this. So the the line that's traced out by a sprinkler, um, has really nothing to do with the instantaneous velocity. It's really about the history of where that water was released, the velocity as it moves, and integrated over time. And so it can be like somewhat complicated. But that is basically what a streak line is. You're basically following what happens to, or so the definition is basically it's a curved line formed by a string of fluid particles, so like a connected bunch of fluid particles that have been released or passed through a certain point in the flow. So usually it corresponds to something like, oh, I'm trying to study a flow and I'm going to release, let's say, smoke from a particular point over here. That smoke makes basically a continuous line, and what it looks like at any instant is basically, called a streak line. So if the source moves or if the flow is transient, this is actually not the same as a path line. But it often is the same as a path line if the flow is not transient, in the sense that like the velocities at any particular point, if those don't change over time, then the then the path line is the same as a streak line. But if the source is moving or if you have like a turbulent flow or something, these two things won't be the same.